Hello everybody, Namaste. My name is Anushka. I'm studying in Sri Venkateshwara College of Engineering, and today we'll be discussing about need of cache memory. Today we'll be talking about what are computers and cache memory. So what exactly is a computer? It is an electronic device that is designed to accept data, perform the required mathematical and logical operation at high speed, and output the result. Talking about its characteristics, we have speed, storage, accuracy, versatility, and connectivity. Have you ever wondered how does computer access this memory so quickly, or how does it work at such great speed? That is because of memory. And computer has its own memory. We as humans allocate memories to people, places, location. So does our computer, and that's how it works. Now we'll be talking about cache memory. In this, we'll be discussing about what is cache memory, how cache memory exactly works, types of cache memory, its benefits and challenges, and at the end we will conclude. Coming to introduction, a vital component in modern computer systems. Have you ever wondered how your computer can access frequently used data so quickly? The answer lies in cache memory. Cache memory is like a secret weapon for your computer, allowing it to access frequently used data at a lightning speed. It's like having a personal assistant who anticipates your needs and has everything ready for you before you even ask for. But how does it do it? Let's find out. Cache memory is a type of high-speed memory that stores frequently accessed data. It is located close to the CPU, which allows for faster access to this data than it is when it is stored in RAM or on a hard drive. RAM stands for random access memory. The reason cache memory is so important to computer performance is because it helps reduce the amount of time and CPU has to wait for data to be fetched from slower storage devices. By storing frequently used data in cache memory, the CPU can quickly access this data without having to wait for it to be retrieved from RAM or the hard drive. This results in faster overall system performance. Moving on to types of cache memory, we have L1 that is level 1, L2 level 2 and L3. Talking about L1 level 1, L1 cache is the fastest and smallest cache memory that is integrated into the CPU. It stores frequently accessed data and instructions, enabling the CPU to access them quickly without having to go to the RAM. RAM again stands for random access memory. These memory caches are inbuilt in the architecture of microprocessor and are internal caches. So for example, we have Intel 80486 microprocessor has an 8K memory cache. Coming to L2 level 2, L2 cache is larger than L1 cache and is located on the CPU or on separate chip. It could also be on motherboard. It stores additional data and instructions that are not frequently used but are still needed for our CPU. We have L3, that is level 3. L3 cache is the largest and slowest of the three types. It is usually located on the motherboard and serves as a backup for L1 and L2. So it's not frequently used, but the computer still needs it. Moving on to how cache memory works. The process of how cache memory works involves the CPU constantly checking the cache memory for data it needs. If the cache data is not found in the cache memory, the CPU retrieves it from the RAM and stores a copy of the data in the cache memory for further use. That's how we access the memory frequently. The cache memory is designed to be small and fast, allowing for quick access to frequently used data. While the RAM is larger but slower, this combination of different types of memory allows for efficient use of resources and improved computer performance. Cache memory is a type of high-speed memory that stores frequently used data for quick access. When the CPU needs to access data, it first checks the cache memory to see if the data is already there. If the data is found in the cache memory, it can be accessed more quickly than if it had to be retrieved from the slower RAM. This is how computer works in a very high speed. Coming to cache memory in action, cache memory plays a critical role in improving the performance of the modern computing systems. It helps reduce the time it takes for frequently accessed data to be retrieved from the main memory, resulting in faster system response time. understand this with an example. One example of how cache memory is used in the real world is web browsing. When you visit a website, your browser stores data such as images and scripts in its cache memory. This allows the browser to load the page faster on subsequent visits. As it can retrieve the data from the cache instead of downloading it again from the internet. Similarly, in gaming, cache memory can be used to store frequently accessed game assets such as textures and models, resulting in smoother gameplay and faster loading time. Coming to its benefits, cache memory provides several benefits to the computing system, including faster access to frequently used data and reduced latency. By storing frequently accessed data in cache memory, the system can retrieve it quickly without having to access slower storage devices like hard drives or solid state drives. In addition, cache memory can also help improve system efficiency by reducing number of requests made to slower storage devices. This can result in faster processing times and improved overall system performance. For example, web browsers often use cache memory to store frequently accessed web pages, allowing them to load more quickly for the user. Now let's talk about its challenges. Challenges of cache memory. One of the challenges that can come with using cache memory is cache coherence. Cache coherence refers to the problem of ensuring that multiple caches in a system have consistent data. When multiple processors access the same data, each processor may have its own copy of data in its cache. If one processor updates the data, then the other processor needs to be notified and their caches needs to be updated as well. This can lead to performance issues and requires additional overhead to maintain the consistency. Another challenge is cache trashing, which occurs when the cache is constantly being flushed and refilled with new data. This can happen if the cache is too small for the overload or if the program has a poor locality of reference. To overcome this challenge, some systems use larger caches or smarter algorithms for managing cache content. In conclusion, cache memory plays a crucial role in modern computing systems by storing frequently accessed data closer to the processor. Cache memory significantly improves system performance and efficiency. As we have seen, there are different types of cache memory, each with its own pros and cons. However, despite the challenges that comes with using cache memory, such as cache coherence and trashing, many systems have successfully implemented it to great effect. Therefore, it is highly recommended that you consider implementing cache memory in your own systems. Whether you are building a gaming PC or a data center, cache memory can help you achieve better performance and efficiency. So don't hesitate to explore the different types of cache memory and find the one that best suits your need. Thank you. I hope this video was informational. If you liked the video, please make sure to give it a big thumbs up. Till then, will see you in the next one. Thank you.